Well, hey everyone, I think we're live. Thank you all for coming out to join us for another episode of Howdy Partner. Super excited for today's episode. As you may have noticed, we have a brand new co-host with us, Stuthi, and you'll hear from her a little bit later. And we're super excited to welcome Mobiquity to the stream, and they're going to talk to us a little bit about Amaze, a product that they built to help people with the heavy lifting of migration, really. And so, Mobiquity folks, can you just do a quick introduction to yourself?
Yeah, hi everyone. I'm Vinod Arjun here. I'm the product owner for Amaze, responsible for all the requirements, new features, and the go-to-market strategy. And I'm happy to be here to demonstrate the features of Amaze along with my colleague Chirdi. Over to you, Chirdi.
Hi everyone, this is Chirdi. I'm working as head of Amaze product, and my responsibilities include creating and advance new features into Amaze and basically help customers do replatforming and cloud migration using the product. Thank you.
Awesome. Yeah, great. Now, to get started, Stuthi is going to be talking to us a little bit about migration and just kind of what is the problem statement that we're running into today. So please, Stuthi, go ahead and turn the time over to you.
Thank you, Daz. Hey everyone, this is Stuti Deshpande and I'm a partner solution architect at AWS. So let's talk about the top migration challenges that we hear from our customers. Lots of challenges are with the existing software, license, and vendor willingness to price reasonably during the move of hundreds of vendors. They want to kind of evaluate and onboard new software vendors during the migration. They also want to bring the on-premises capabilities and controls related to security or compliance to cloud applications. And more than the technical, there is a conflict when it comes to the people and the culture of big organizations. So there is a lot of drive that needs to be done to change and have that cultural change beyond IT as they transform their businesses to digital and they migrate from on-premises to the cloud. So today we are going to address these challenges and discover how you can quickly and easily move to the cloud. Because beyond these challenges, you will experience the world of benefits of moving to cloud. And those are basically five folds. The first one to go with is agility, meaning that you can quickly spin up resources and quickly build and deliver new applications. So you have so much of ability to develop and innovate applications more frequently than you might have done it before. And second, with the elasticity, right? Like you can scale up and scale down your resources based on your workload requirements, and as soon as it changes, you can cater to those kind of workload changes requirements. You can start very small and then can grow up and down. And then with the cost, right? Like if you see most of the people moving to cloud, always the conversation starter is the cost. Moving to cloud will actually help you trade your capital expenses with a variable expense. What I mean to say is you pay for only for what you use. And then you have fully managed services where you don't have to do any kind of infrastructure management, and all those kind of heavy lifting work is taken care of. And then you can go global in minutes with the availability that AWS has with 76 availability zones spread across 24 geographic regions. And to kind of summarize, and in order to enjoy the benefit of cost takeout, the companies need to push through the last mile of their modernization process, and that is the refactoring of applications into a serverless architecture and containerization. Almost 81% of all containers in the cloud are actually running on AWS as of today. That's because of the choice that we offer to our customers. We offer a managed Kubernetes service, that is Amazon EKS, and as well as our own container service, which is Amazon ECS, Elastic Container Service. So it really depends on the customer to choose from. If you prefer the service, which is mostly integrated with AWS platform capabilities, you can have ECS. If you prefer having a managed Kubernetes service, you can have EKS. But if you prefer not to manage any server or any cluster and manage containers at the task level, there you have AWS Fargate. And with the launch of AWS Fargate for Amazon EKS in reInvent 2019, it is so much easier to run serverless container very securely, reliably, and at scale. And that's why 40% of the customers who are adopting AWS for their container service choose AWS Fargate. So today we are going to touch base on all these topics, and we are so excited to have Mobiquity with us. Mobiquity has extensive experience in implementing serverless architectures and refactoring applications, as well as building cloud-native tooling and applications. So without any further ado, and let's not steal their thunder, let's turn over to Mobiquity.
Yeah, thanks, today. Yeah, appreciate that. And today, over the course of the next 1 hour, we will demonstrate how we can take an existing on-prem application that was designed some time back and to truly deploy it on cloud in order to accomplish all the scalability features that Shruti just mentioned. So let's get started first on the problem statement that we had done for one of our customers. So on the left of the screen, you can see a typical J2EE application developed about 7 years back. And as you can see, it's a typical WebLogic architecture. And this is an e-commerce application developed for a brick and mortar store. However, with the new digitization that's coming up, the same organization, wanted to modernize this whole application so that they can convert that into a true digital format. And some of the features that they were looking for was they wanted to support 2.5 million visitors per day, going from the current. I'm sorry, Dave, any question?
Yeah, sorry, can you hear me?
Yeah, I can hear you.
Are you sharing your screen already?
Yes. Okay.
Yeah, go ahead and click that screen share button. I think we're just a step behind you.
Sure. Okay. I guess, yeah. Is that coming up? Okay.
Yep. Okay. Yep. Yeah. Okay. We're good now. Yep. Just go back to the. Yeah. Perfect.
Is it good?
Yeah. Yep. Yep. We are good to go now.
Okay. Great. Yeah. Sorry about that. So the image on the left is a typical architecture of an on-prem Java application deployed on a WebLogic server for an e-commerce application designed for a brick and mortar store and deployed on an on-prem data center. So this application did its job when it was confined to a brick and mortar application, satisfying about 25 users per store. However, this particular business was looking to completely roll it out into a true digital application so that the entire sales can be rolled out in an online fashion. But once they did that, some of the requirements was they had to support 2.5 million visitors per day. They wanted to support nationwide sales and also integrate into their partners to support the procurement of new products, shipping, payments, etc. And also wanted to build out a brand new web and mobile front end towards the existing architecture. And in addition to providing some complete self-service and straight-through processing, which is an additional feature. And as Shruti said, one of the natural choice for us was to provide a solution deployed on AWS. However, we were having two choices. One was, do we completely rebuild the entire application from the scratch, or do we re-platform and refactor this existing application? If we were to completely rebuild it, the estimates were running into at least a year of time. and the cost was significantly higher. The other alternative solution was, can we re-platform and refactor this application and deploy it into cloud, in which case all of the features can be met, and as well as we can do the entire thing in 6 weeks. So naturally, the customer chose the option of re-platform, and we decided to use it using Amaze, which did bulk of the heavy lifting and automating a lot of these activities, due to which we were able to deliver this new application deployed in 6 weeks. So today we are going to literally walk you through how we went about accomplishing that, and how the step looks like, and what activities Amaze does and what was manual, and to walk you through this entire process. So we are going to literally show you how we took this application, and then we made all the changes using Amaze manually, and then deployed it into AWS. So that's going to be the agenda for today.
Yeah, I'm super excited about what we're going to see. So I know a lot of people will ask me what should I do? Should I refactor, or should I just lift and shift? Should I just move it up into the cloud? And that's a tough question. A lot of people do ask that. But what you're showing here, what I think is amazing was that that time frame there, 6 weeks. 6 weeks, that's pretty quick. And so everybody has to make the decisions for themselves, what is best for their customer, for them or their companies. But in some cases, just getting that up in the cloud as fast as possible is, in many times, the best option for them. So I'm excited to hear about how you did that, and even more excited that in the next 90 minutes or so, we'll be able to see that whole thing.
Sure, absolutely. And that's really the agenda for today. So how we went about doing that is really explained in this one slide. So this entire process was a 3-step process. So the first step is what you see here is the assessment, where we used Amaze in order to analyze the current application and create an assessment report, which pretty much has 2 important parts, which identifies all the code blockers in the current code, and also gives you vital intelligence that will help you to design the new application. That's the assessment part. Then the second part was the actual replatforming, where you run Amaze and it makes all the code changes in order to create a cloud-ready application. And that's the part my colleague Chirodeep is going to walk you through. And the last part that you see on the right side, or the step 3, is the integration. All of these services that Amaze creates has to be integrated to create a fully functional application, which we'll walk you through as well. So with that, we are going to pause here and then quickly show you a demo of how the assessment works. And here I'm going to ask my colleague, Chirodeep, to go ahead and run an assessment, kick off an assessment, so you can understand how it works. This entire assessment process typically takes about 20 to 30 minutes. However, once that is kicked off, I'm going to walk you through a report to show you how it works. So I'm going to stop sharing, and Chirodeep, can you kick off an assessment for me, please?
Thanks, Vinod. Can you see my screen?
Yep,
yes,
we can. Let's resize that a little bit.
So what you're seeing here.
Yep, go for it.
So what you're seeing here is an Amaze workbench that's going to be used for assessment. It's a fairly simple and fully automated process. Here you can see that Chirodeep is just choosing the source folder. You have to pick the root file of where your application resides. And once you select that, Amaze is smart enough to understand the entire code structure, and it will start analyzing. This entire step takes about 25 minutes. So in the interest of time, what I'm going to do is I'm going to walk you through a report that we generated a little bit earlier, because we wanted to complete this entire show within about 30 minutes. So now I'm going to share my screen again. So while that report is running, I'm going to switch over and then show you an assessment report that was just generated a short while back.
Okay.
Yeah, so can you all see my screen? Taze, can you see my screen?
Yep, let me just re-enable the screen share view. Yep. We should all be able to see it.
So this is a view of an assessment report that gets generated by Amaze. As you can see, this is a HTML interactive report that gets fully generated in an automated manner. And it typically takes somewhere between 25 minutes to an hour, depending on how big and complex your application is. I will walk you through all elements of this report to show you how comprehensive it is, and also to give you a view of the level of depth and detail that it provides. So I'm here right now
just to clarify, so we got this doing just exactly what you just demonstrated there, right? We just pointing it to that code base, it generates this whole thing for us.
Yes.
Oh, that's awesome. Okay, cool.
So, yeah, so it, as I said, it takes about 25-30 minutes. That's about it. And if you were to do this manually, in most cases, it's probably going to take about 25 to 30 days, typically, give or take, for a medium-sized application that's about 250,000 lines of code.
Yeah, not something I wanted to.
Right. So right now I'm in the application snapshot. So this tab is more of an executive summary of your application, if you will. It gives you a high-level overview of all important elements related to cloud replatforming. So under the containerization readiness, here it tells me that 31% of the code will need refactoring, while the rest 68% is good. So that's the level of code change I have to do if I have to containerize this application. Now going to the next section here, this tells me that if I were to re-platform the application server, which is going from JBoss to Tomcat in this case, about 35% of the code will need refactoring. And the next section here is for message broker. A lot of applications developed maybe about 5 to 10 years ago will have some on-prem message brokers like TIBCOs, IBM integration brokers, web methods, and so on. Most of them don't work on cloud. So in order to replace them by an active MQ, it tells me that 80% of the code will need to be refactored here. And going to the right, this is the batch programs. For example, this particular application used Autosys Scheduler. We all know that does not work in cloud. So in order to have it replaced by an AWS batch, it tells me that about 75% of the code will need refactoring. So as I come down, the two pie charts give me a complete technology-based breakdown of the application. You can see the pie chart on the left is giving me based on number of files, and the one on the right is based on lines of code. So this gives me a detailed breakdown, and this will really help me to come up with the effort estimates and planning for this replatforming exercise. And as I come down, so you get, as I come down, here it tells me that if I have to replace the scheduler, in this case, it's an Autosys scheduler. If I have to replace that one AWS batch, it tells me that 70% of the code will need refactoring. And as I move towards the right, this application uses 3 databases. And if I were to replace that database towards a more efficient Postgres on AWS, it tells me that about 2.6% of the code will need refactoring. Similarly, as I come to the right, after analyzing the current build files and the automated test cases, Amaze was also smart enough to calculate the CD and CI readiness here, which tells me that CD is about 72% and CI is 93%. If you want to deploy it into cloud, we want 100% readiness here. So the deltas is what Amaze will help us do that. And the last one is the macro and micro API readiness, which Amaze analyzes the current code and tells us how many macro APIs are currently there and exposed. Macros are your business APIs and micros are your granular data access APIs. So this is how many are exposed. And as I come down, so here you can see you get some details about the middleware platform. This application is running on WebLogic with the WebLogic NQ as the message broker and AutoSys for the scheduler. And as I come down, you get a complete inventory about the databases. For each database, it tells me how many views, tables, stored procedures, triggers, sequences, and others are there. So this is for the first database, and this one is for the second database, third, and the fourth. So, and you can see now for each one of the databases, we also capture what's the version number that's being used along with the size here. And all the database inventory is captured along with even if there are any DB links there, which will help us to design the database migration as we go into cloud. So as you can see, we get a complete list of the entire inventory of the database here. All of that was generated by the report. So I'm just quickly going down, and this section is another interesting one. As you are moving to cloud and you want to containerize this application, a lot of your underlying libraries will have to be changed because your Docker container dictates that your JDK has to be 1.8, and the moment you have to upgrade your JDK 1.8, a lot of the other libraries will have to be upgraded in order to ensure compatibility. So Amaze is also smart enough to analyze the libraries, and it tells us all the libraries that are likely to be changed or will have to be upgraded. So all the ones on the red are the ones that have to be upgraded. You can see that you have one here in green says unlikely, meaning that does not have to be upgraded. So it tells us the quantum of work involved. And the other interesting thing is a lot of these upgrades Amaze can handle automatically as well, which my colleague Chirudeep will be demonstrating it shortly. So this is the complete inventory that you have of the application. So now I'm going to quickly scroll up and go to the next tab, which is a containerization readiness. So here, so when I'll come back. So earlier we said that 31% of the code will need changes. So that's just a high level number. Now under the containerization tab, it tells me that within the 31%, all the places that I have to change. So this pie chart tells me that among the 31%, 4% is in your POJOs, about 3% is in your session EJBs, 1.2% on your JSF, and so on. It gives you a more granular breakdown. And more importantly, these line items here list all the program files that you have to make changes. And for each change, it lists the program that you have to change, the reason, which is your blocker, and what's the impacted code that you have to change along with the line number, and also an indicative efforts if you were to do it manually. This is based on some intelligence. Here is where it gets interesting. If I click on any one of these links, these are hyperlinked. It takes me towards the actual code and highlights all the lines that I have to change on a different color. So you can see how granular we go and how detailed it is. So all the lines that I have to change are really highlighted on a different color. You can see here, these are all the ones that we have to change because you do have a code blocker here that's going to prevent you from going to cloud. So that's the level of granularity that we do. And when I come back here, you can see that we list almost every change that we have to do. And now we are fairly confident enough to state that the accuracy of these issues is as high as upper 90%, like 98, 99% accurate. There may be 1 or 2% that we don't catch, which we are constantly upgrading, and the accuracies are increasing. You can see we catch almost all the changes that we have to do. The interesting thing is not just the changes, we also, Amaze can also make the changes.
Quick question from the chat. AM Grob asks, what languages does this work with? So like we can see Java, it looks like there's been a lot of Java stuff. What type of languages and technologies do you support?
That's a great question. And Amaze supports 2 languages, Java and C# developed on .NET. Those are the 2 languages or technologies that we support.
Okay, awesome. If I remember correctly, Mr. AM has some love for the C#, so that'll be good news for him.
Great. Okay, so that's on the containerization. Now I'm going to the re-platform readiness. So this tab highlights all the changes that I have to do in order to re-platform this WebLogic application towards a Tomcat. So that's the structure is similar. You have the pie chart giving a high-level breakdown of the changes, and as you go down below, we list all the program files where a change has to be done, along with the reason for change and which line number. And as before, if I click on that, it takes me towards the actual file where I have to make a change. So it's pretty detailed and granular. Since the structure is same, I'm going to skip on this section a little bit quicker so that I can give more time for Chiradeep and spend time on the actual code transformation, because that's really the key value of Amaze. So now I'm into DevOps readiness. Here we analyze the build files, unit test cases, functional test cases, and capture what level of automation is there in the current code. So you can see that the current automation is about 29%, and we list also all the unit test cases that are there, which will have to be changed as we make changes here. And in addition to it, we also analyze your build files and capture what level of build automation, CD automation, CI, and infrastructure as a code automation is there as well. So all of this will help us to design and plan for the replatforming activities. Now I'm going to the macro and micro API sections. So these 2 sections give us intelligence into the current code, and these are mainly used for designing your new application. So as said earlier, macros are the business APIs. So you can see that we list all the files or APIs that are currently exposing the macro APIs, along with the technology as well. For example, if I take customer notification service.java, it's a J2E, meaning it's an EJB. And in this case, it happens to be a message-driven EJB, and it is tied towards a customer notification service. And this is the interesting part. It says that it's currently false, meaning it's not API enabled. However, in the new application, you can API enable. In the earlier business driver, as I told you, their primary goal was to digital enable this application and to build out a new mobile and a web UI. So for that particular case, it's a good idea to expose all of these APIs as services, so that it will help us to build the new Angular UI and the mobile API better. So in that case, we would expose all of these APIs, enable them, and as well as create more granular services that will help us in the scalability. But this is purely a design choice. What API that you want to enable and how granular that we want to go, it's purely a design choice. And we can go as granular as we want, or coarse grain as we want. So
if we wanted to enable those, like what would be like the level of effort? What would we have to do to enable them to make them API enabled?
So Amaze will do it. In the next step, when Chiradeep is going to run Amaze, you will see that we will have to specify this data into Amaze, and it will generate those APIs. So the bulk of the heavy lifting Amaze will do. However, integrating that later on, that's a manual activity that you would have to do it.
Sure. So we have a question in chat from Lord Lehan, and they ask, does Amaze generate any code throughout this process?
Absolutely, it does, and you will be seeing that on the next step, where Amaze will it will analyze your current. In this step, it's analyzing. In the code transform step, it's going to read, analyze your current on-prem design patterns and convert that into cloud-friendly design patterns. For example, all your EJBs will be converted into a Spring framework or a Spring Boot Pojo application. So Amaze will do that, and you will see that on the next step.
Awesome. Yeah, we're excited to. We'll be excited when that comes.
Great.
Yeah, go ahead. Just 1 second. We're about 30 minutes into the stream. Stuti, do you mind just doing a quick recap? Why are we here? Who are we talking with? For the people who have joined in the past couple minutes.
For sure. So those who have joined pretty much late, we are here to discuss about migration challenges, and we are here with our partner Mobiquity. We're talking about their amazing product, which is called as Mobiquity Amaze. And we are kind of just diving deeper into the migration challenges and how it can be overcome using this product, and going over some reports.
Yeah, and so far what we've been able to see is a sample report that was generated by the Amaze product, and basically it's a breakdown of all of the steps that you need to be able to migrate your application. Stuti, were there any like favorite parts of that report that you saw, like when we were going through it, that you just like thought was really cool?
Yeah, I think the part that it can support multiple languages, and then the deployment scripts that were shown, like the graphs, and those are pretty cool.
Yeah, I thought just on that first page that we saw there, where it showed like the percent, like the percent that it's ready for migration, like I think that's so valuable. Just like even if that's all the tool did, which I think we're going to find out later on that it does a lot more than just this report. But if all it did was just say, oh, yeah, you can do 80% of this you can migrate easily, and maybe 20% is manual work, that information in and of itself, as you're trying to plan for future migrations and stuff like that, is just so valuable. So, yeah, it's been super, super awesome. And we have another question here, and it's, does Amaze support different deployment models on AWS?
Yes, absolutely yes. And whether you want to deploy it into a container or into a Kubernetes framework, Fargate, Amaze supports different deployment models, and the choice is purely ours. As you feed in the deployment models, Amaze will create the deployment scripts, which you will see on the next step.
Okay, awesome. So we have another question here. So basically what we have going on is like, as far as like the migration stuff that we're going, so like what was asked is like we can go like Stretch to Spring MVC, SOAP to Spring Boot REST, and MDB to Spring JMS. Is that kind of what we're thinking, how we should think about it?
Yes, right. Our target framework for the most part is going to be Spring. So,
okay.
So that's the framework. So if you have an EJB based application, we will convert all of that into a Spring framework.
Okay, awesome. Yeah. Cool.
Okay.
And thanks, chat, for the questions. Keep them coming.
Sure. So on a similar note, micro APIs are for data access APIs. So just like your macro APIs, here we list all of your data access APIs along with the program type and the services associated with, and whether it's API enabled or not. And as I said earlier, this is very vital or critical information for us to design your newly replatformed application. So based on your business goals, We can go, as granular as we want or as coarse as we want. So with that, I'm going to pause here and then hand it over to Chirudeep, who will be covering the second part of it. So let me quickly. We'll be covering the second part of the demo, which is going to be the code transformation. So let me come back to the screen and show you. So what we had seen so far is the assessment and the report was generated. Now what you're going to see is the one in the center where you will see Chirudeep run Amaze to do all the code transformation, which includes breaking macro into microservices, generating the build scripts, and going all the way till the deployment. So I'm going to pause here and then hand over to Chirudeep to show you the actual transformation. In fact, this is the most valuable feature of Amaze, and we'll quickly spend some time on that.
Awesome. Before we get into that, one quick question we have is, are we able to do, for .NET, do you go .NET to .NET Core? Is that the migration pattern that we're looking at there?
Yes, .NET to .NET Core.
Great.
.NET to .NET Core, and you can also replace IIS server with Kerstal server, which is a lightweight, cloud-friendly server as well.
Sure. Wow, that's awesome. Cool. I will share the next screen. I'm excited to see the next part of this. Great. Okay, we can see your screen.
Okay, thanks, Vinod. Hi, Taste, can you see my screen?
You can. Yep, we're good to go.
Yes, go ahead, Chirudeep. We can hear you.
I'm going to show you the next part, which is the actual replatforming of Amaze, where a particular application will be taken and will be migrated to cloud native application. And before I run that, how the original application was. So this is the application which I'm taking as an, and this application is using one Oracle database, one DB2 database, one SQL Server database, and one Sybase database. So through this replatforming, we will show how.
Chirudeep, your audio is not coming in clearly, so can I cover the audio for you?
Okay, Vinod, sure.
Okay. Okay, keep going, and I'll do the voiceover since your audio line is, there is a challenge. So what we're seeing here is Chirudeep is walking you.
Yep, we can hear you.
Okay, so what you're seeing here is Chirudeep is walking you through the current source file of the existing application. It's got 3 databases, and now you're seeing all the different EJBs that are there. As discussed earlier, this is a WebLogic application. These are all the EJBs that's currently being deployed on WebLogic, and these are all the services that are there, or EJBs, sorry. You can have a combination of stateless and stateful EJBs in here. So that's your current current application, and now he's walking you through the web application component, and there's a web app as well. So this is your current application. So now what he's going to do is he's going to execute Amaze here. So this is the same interface as before. However, now he chose the code transformation as an option. So the moment you select that, you have to specify a lot of choices. So we will go through it one by one. So here you can see that the first is the type of of replatforming service that you want to do. There are three options there. So what we are going to do is a containerized web front and database decoupling. So which basically is it's going to separate your web front and back end, and then break your monolith into granular services and do database replatforming as well. So that's the first step. And the next one, what you're seeing is that desired automation level. So here, what you're seeing is the language. This application happens to be Java, so that's being selected. Then the WebLogic server and the message broker, scheduler, and the database. So all of those options are being selected. So this is all for the current application. So now you go to the next tab, which is your target. So in this, there are two options. Since it's a Java application, the target is going to be Spring Boot. Then your application server is Tomcat in this case. Your message broker will be ActiveMQ, and your scheduler will be AWS. And for database, we are choosing Postgres. So once we choose this, then we go to the next tab. And in the next tab, we are going to select which is going to be the target folder where you want to deploy this, where the newly generated code is going to be deployed or it's going to be placed. So he's selecting that. Now we are going to click on generate. So the moment you click on generate, now Amaze goes to work and it's going to do all the automatic code conversion of your on-prem design patterns to cloud. And it's also going to take care of replatforming your EJ into a Spring Boot framework. This entire process is going to take somewhere between an hour to almost like few hours, depending on how complex your application is. So now while that is running, we are going to quickly go ahead and show you how a generated code would look like, because this is going to take time.
Yeah, so now, I've got a question in the chat. So we had the option to choose Postgres. Is that Aurora or RDS Postgres?
Yeah, can you repeat that, case? I could not hear the question clearly.
Oh, sorry about that. So the question is, with the Aurora selection there, not Aurora. When you select a Postgres, what is that Postgres running on? Is that on like EC2, RDS, Aurora? Where's that going to be running?
Yeah, this is RDS, Postgres on RDS.
Okay, great. Awesome.
Yeah.
And then we have another question on the chat. If Amaze can break down my monolithic application to multiple domains if we decide to migrate to a microservices architecture. And this question is from Lord Lahim.
Yeah, what we do is we break the monolith into granular services, and each one of the either you can go granular where each of the EJBs can be broken down into an independent services, or we could even combine several of the EJBs into a service. So that level of granularity is provided by Amaze. Either you can choose the default option that Amaze provides, which takes into account how the current code is written, or you can choose a user-defined option where you can specify how granular you want the new code to be decoupled into.
Okay, great. Thank you.
Awesome. So it sounds like there's just a lot of options for people, like depending on what they need.
Yes.
It's awesome.
And in fact, this is a very important step where we would have to really, specify how you want your new code to be generated, and this is why it's important that you have a design in place based on your assessment report.
Okay, awesome.
Great.
That's great. Keep the questions coming.
Sure. So Chirdeep, now can you go and show them the generated code? Yeah. So here what you're seeing, hey Chirdeep, why don't you, I mean, if your audio is better, you can try explaining, otherwise I will chime in. Yeah, Chirdeep, can you try to speak up? Yeah, looks like you're still having some challenge. Okay, so what you're seeing here is the DDLs that got generated by Amaze. So Amaze, reads your current database objects, and it automatically creates the DDL here. So that's what Chiradeep is walking you through. So using this DDLs, we can by running these scripts, we can create.
Oh, I think did we lose him?
Is the DDLs for the second database here.
See here, I think, okay, you're back.
Awesome.
We had a slight drop there for a second, but I think we're back.
Okay. Hey, Chirdeep, if you have an audio, can you speak up to see if you have an audio? Okay.
Bear with us for a second, folks. We're just doing some audio testing. The fun of a live event going on right here. In the meantime, oh, yep, we can hear you.
Yep. Positive.
Very good. So as we shared earlier in the assessment report, there were 4 databases. One was DB2, one was Oracle, one was SQL Server, and one was Sybase. So while we generated, all of these databases were converted to Postgres version, and I'll show you how typically the challenges were handled. In the original database, if you remember the assessment, they were all @ in Sybase. You see in Postgres converted database, though all the @ has been converted. It's all declarative parameters which comes in Sybase as @ which has been removed. Similarly, for Oracle database, there were n varchars. So all these n varchars have been replaced as varchars, and similarly, all decimal has been converted to numbers. So all those syntaxes which are having one-to-one mapping in the dictionary of Amaze, this automation can literally convert any database to Postgres database. Now that was about database. Now let me show you the original application, as I showed you, was monolithic, and for the assessment you saw that it has identified all the services. Now this is the automated generated source code which I'll walk you through, has converted the complete source code from EJB to Spring Boot application. So this is the service where it has generated the Spring Boot form file with all libraries, latest libraries, and for example, Hibernate 5 has been upgraded, Spring 5 has been upgraded, Postgres database library has been added, and OpenAPI for API generation, it has generated OpenAPI Swagger API conformance, and it has generated Docker file. And the beauty is it has converted all the services from EJBs to normal POJOs, which is, I showed you the EJB. Now you see the corresponding POJOs, which have been converted to a Spring transaction, and all EJB references have been removed. This is the original service which for EJB, and it has been converted to POJO service. Plus, it has generated the REST wrappers in form of the controller. So you see, it has integrated the service automatically with the controller and it has generated REST APIs. It has generated wrapper JSON objects to ease the passing of parameters for post. Automatically created wrappers. It has created the REST templates, that is the caller programs. If you see EJB, the caller programs would have called by remote home or local home, and there would have been a lookup, and then by that home reference it would have called. This is the REST generated macro service with the REST template, which just needs to be plugged in place of the original lookup, and the integration will be a piece of cake, just a one line chain. Additionally, it has generated all the test cases for every API it created. So it had one API, it has created the test case for that. Along with the individual, each of the macro services identified, which are business services, it has generated complete independent application incorporating all the dependencies which the application had. For an example, it has taken out the model which were having dependency. It has taken out the constraints. It has taken out the utilities, and it has precisely generated an independent application with minimal code, which can be deployed as an independent unit and scaled up infinitely. Now this is the data API which is created for same way it has created the data API, and it has generated 1, 2, 3, 4, 5, 6, 7, 8, 9 business APIs, 10 business APIs, and all the data APIs. So these are the data APIs.
That's awesome. And so these are all things that were able to be generated, honestly, with just a few drop downs and basically post scan. You just told the application what you wanted, and it generated all of this on its own. That's pretty awesome.
Yeah. So one point I just want to highlight here that let me just bring up one slide and let me know whether you can see this slide. So while running Amaze, there are some design decisions as we were showing. So we can break the monolithic application into web front and backend, and then break the backend into small macro services. There are 2-3 reasons why we are doing it. While there is a business angle for exposing API for mobile and digitization, there is another angle to it because we are trying to convert an EJB application running on extra large application servers like WebLogic to open source mini servers like Spring Boot Embedded Tomcat. Obviously, the application, if it is monolith, it won't run in that environment. So we have to make it small and granular, independent of each other, and that will help in also reducing the container image size, also scale it up infinitely. For an example, if you see the left side, if you consider this as a session EJB, inside WebLogic container, the number of instances in free pool would have been limited. So in order to scale up the application, the only way that could have been possible is to horizontally or vertically add nodes to this server cluster for higher scalability. But in the target space, because we are converting each application as an independent running containerized application, based on the container environment and container configuration, each service can independently scale up each other. Plus, because we are introducing CI/CD at each service level, each service can be deployed separately of each other, and the velocity and the agility of the application will increase manifolds.
That's awesome. Hey, just to kind of interject for a second, we have a few questions in the chat from some of our viewers, and they're wondering about unit testing. Are there any automated unit tests that are generated as a result of these scans or anything like that?
Unit test cases we are not generating. We are generating functional test cases of all APIs created automatically.
Okay. And another question is it possible to integrate this tool with an APM such as like Dynatrace for unit testing of the newly generated code?
As Vinod said, we are actually improving and creating more features to MS. If there's a requirement like that, then definitely we can think of integrating. As of now, the feature is not there.
I love that answer. That feels like such a customer-obsessed Amazon answer. You know, if we don't have the feature right now, then like let us know because we want to build it. So I like that answer. So it sounds like, you know, if that's something that you're interested in seeing, reach out to these guys. Let them know your ideas and everything, because it sounds like they really would like to continue to grow the platform. So thanks for those questions.
And out of just the curiosity, I would like to ask a question here. Since the user has the option of to select which automation they would want to go with, what is the typical duration to re-platform an application to AWS? Do you have some metrics around it?
Yeah, in most cases, it's about 4 to 6 weeks.
Wow, that's amazing.
Yeah, that's a typical timeline. If you have a very large application, it can take a little bit longer, but our typical duration is 4 to 6 weeks.
That's pretty fantastic.
That's perfect.
I'll show you how it is being made possible, because I'll show you the output generated, right? And then there's, as Vinod suggested, shared, that there's a manual fine-tuning done to the application by MS consultants, where there is any missing library added, where there is integration components added, code is made completely runnable and deployable. So that is a small amount of work, and then I'm taking the output fine-tuned previously by consultants and showing you how this can, how this basically runs. This is the output of MS, and I'm going
to
hey, your audio's a little bit choppy again, it sounds like, from some of the viewers. Maybe if you move the mic a little bit closer to your face, what it sounds like is it has like almost like a noise canceling feature, or something that's like disengaging.
Is it somewhat better?
I think for now, yeah. Let's give that a shot, and we'll see.
I'll try to build and run the application generated by MS.
So while this is running, I would like to make one comment. Until now, all the code that you saw was completely generated by Amaze and no human intervention. And Shirodeep is building those services, so you will see those services getting built and deployed independently. So until now, there's no human intervention. Everything is automatic code generation. But there is some manual effort involved, which we will talk a little bit later. That will be step 3.
Awesome. So another follow-up question people are asking right now is, it says 4 to 6 weeks probably doesn't include integration with like the on-prem security framework, would it?
No, the integration we would do it, but however, what is not included in that is you might have to do a thorough, full, functional testing end to end. So that will take some time. So typically in a project like this, we don't do the complete end-to-end functional testing, mainly because our team will not have the functional knowledge. So we recommend customers to do the testing, and we will support them if any issues are found. So that functional testing and SIT process can take anywhere between few weeks. It will vary from application to application and customer to customer. So that's not included in this. The 4 to 6 weeks window of time, what I said is This code transformation, any development activity, and unit testing. All of that is included in that.
Okay, awesome, cool. Thanks for clarifying.
So now the ML generated code is getting compiled, and we are running the each macro service. Picked up one macro service and started deploying. It has deployed and is showing catalog service. So let me now open my browser. This is the Swagger page which has opened up. So I will do one thing.
So what you're seeing now is the monolith application was broken into smaller modular services by Amaze, and each one of those services was built and deployed, and now that's being tested on the Swagger. So we are testing each one separately. Once this step is complete, then we'll go to the next step, which will be the integration process. That will be step 3.
So you're seeing that ML generated services are getting compiled and installed and built and run. Now, next step is the integration and security and all testing, etc., which is going to be done by an MS consultant or team of MS consultants, and that will be taken care of to the level of production level readiness. You know?
Yeah. So now we'll go to step 3. So far what you have seen is step 1 and 2. Next we'll go to step 3. So that's going to be the integration part, where all of those independent services will be integrated together, including the security framework, and as well as along with the web front. So now I would like to, along this way, there are certain, best practices and as well as some potential pitfalls that we have to be cautious about. So I would like to have Sudhakar, who is also on this call, who is heading the implementation of Amaze project. So I would like to invite him to talk about a couple of best practices that you have to follow as part of the integration activity as well. So Sudhakar, can you?
I'm just going off to keep the number 4.
Let's see here.
So looks like, okay, he's on mute. Okay, in that case, Shiradeep, you might want to go to step 3, walk them through how this integration works, how you integrate all the services together.
Okay, sure. Back to ML generated code. So I just showed the macro services last time. Now I'm showing the web front also. And typically what happens is each macro service is exposed as a REST API, which I showed right now deployed. So each one will be deployed on AWS Fargate as a containerized application. The endpoint will be registered in API gateway. And then the web will be also containerized, and first of all, the web will be integrated with the REST APIs, and then it will be deployed as a containerized application either on Fargate or on EC2. So this is the web front where the integration work has happened. So you see here, this was originally a catalog bin where this bin was using. Now the UJB call was earlier. Now We have changed that to REST call, and it has been integrated with the REST template. See, the same method was following EAD. Now it has been converted to a REST call. Right?
Awesome.
And this is the same object which was generated in the server side as the JSON wrapper, which has been integrated. So in a nutshell, nothing in the web front changes, only the EJD lookup was refactored to be replaced by a REST call, and to a REST wrapper, the JSON object was wrapped around and the complex object was created. That was all about in the web front. There was no other change, and the way we could compile the web, front end, way we can compile the web front also. As you see, the entire application was converted to a AWS ready application in kind of not a very big application. And
your audio is cutting out again. Vinod, do you mind clarifying a little bit? What are we looking at right now?
Yeah, so what he's doing right now is, see, earlier in your on-prem application, everything was a monolith, meaning your server side and your web clients was all deployed as a single integrated ear unit. So now what Amaze did was it separated all the backend services, backend code into several services, and your web client also into a separate web client. So now, Thiradeep is walking through the steps in order to integrate both your backend services and along with your web client so that it becomes a fully integrated application. So, and what we are doing is Amaze generates wrappers, which Thiradeep walked through, and how, and you'll have to change a couple of lines of code here and there in order to integrate all of them together to make it a fully functional application. So that's what he's walking you through. And after making those changes, now he's deploying them, and it can be tested on the local environment. So now that's the build process that's going on right now. And once it is built, it can be tested on the local environment. Was that clear, Tace?
Yeah, absolutely. That makes a lot of sense.
Yeah.
So there are some questions in the chat. There's a question. Also, stuff like load testing, pen testing, etc., would be after the 4 to 6 weeks time frame.
The performance and the load testing will typically happen after that. The 4 to 6 weeks is primarily for dev, unit test, or to get it towards SIT ready. As part of the SIT, system integration test, is where you would be doing the performance and load test also, and the fine tuning of the application. So all the testing will come right after that. So we will do some amount of testing, but not complete testing.
So this is what we're seeing here right now. This is the application, right? We migrated monolithic to like more microservice based architecture, and this is the sample e-commerce site, right?
That's correct. Now,
awesome.
Now you can see that the whole the web UI has been integrated. All the screens are coming up, and that's what you're seeing now. And,
awesome.
and as you can see, the amount of manual intervention was fairly minimal. There is, but it's fairly minimal.
Right. Yeah, absolutely. So this actually leads me to like I think probably the most important question of the night. For the hosts on the call, if you all were an animal, what animal would you be? I'm sure that's what the chat's wondering. Stuti, what would you be?
A bird.
A bird?
A bird. Yeah, I can see a bird on screen.
What? That's what you would be if you were an animal?
Well, I have a passion for dancing, so I would be a peacock.
Nice. I love it. I would probably be a dog of some sort, just like a dumb one, like a really dumb dog, not like one of the smart ones that you can teach to do tricks and stuff. I'd just be the dumb one that gets excited about everything all the time and then sleeps all day. So that's, I think, where I would be. So
Really?
what about yeah, definitely. Get excited, then go take a nap. So cool. What about you all? Chiradeep and Vinod.
A dog.
A dog?
Yeah.
I like it. What about you, Chiradeep?
I think we have some dog lovers here.
No,
Yeah,
no. Yeah, me too. Dog is a
three dogs and a peacock. I love it. I love it.
Okay. Can you hear me now, Tej?
Yeah, I can hear you. Yep.
Okay. Till now, whatever we showed, it is deployed on premise. We have not deployed it yet in AWS. Now I will show you the real deployment in AWS using Terraform, AWS CLI.
Okay, awesome.
So this is the Amaze generated output again, where I showed the database, I showed the macro service, I showed the web, I showed the integration, and I ran and showed the output. Now comes the Terraform. Before I go to Terraform, I have to log into AWS and show you.
And so is this Terraform was generated by Amaze, is that right?
That's right.
Awesome.
Just 2 minutes till the AWS Management Console opens up.
Yeah, while that's coming, yes, Sudhakar, are you on the line? Can you hear us?
Yeah, you able to hear me?
Yeah, we can hear you. So while Chiradeep is doing that, as part of the implementation, you had run into some challenges, especially around the scheduler and the Redis cache. So do you want to maybe talk about some challenges and some of the best practices on these two areas?
Sure, Vinod, sure, definitely. So, as you mentioned, like a couple of things I want to mention here as a challenge and how we overcome that. So, thing is session management. So, as we all know, right, like in legacy Java JS application, developers will use the session object to maintain the state, and also the short-lived objects to improve the performance, right? So these session object will be replicated across the node in the app server, so that the user won't feel any difference. If one node is go down, automatically the other node will pick the request and process it, right? The user will never feel any failures in the browser. So now the challenge is like the moment, as Chiradeep shown before, we break the application into multiple pieces, and you will be a separate piece and deploy in separate container. And like how we are going to manage the session objects, and we don't do the code change, so it will be a bit complicated, right? So we don't want to change the existing code much, but still we have to maintain the session. And the challenge is like how we can do that. So we have thought about multiple options. The first option is using DynamoDB. Like we can use DynamoDB as a centralized cache, so that like we can manage all the session objects. And next thing is Elastic Cache. That is Elastic Cache, right? AWS. So there the challenge is like initial version of Elastic Cache doesn't support encryption, but the customer says all the data that needs to be stored in AWS needs to be encryption. Then we went to DynamoDB, but then the challenge is like we have to write a lot of code that need to be validated. You write a lot of unit test cases. Then later we found the Elastic Cache supports encryption in data in transit as well as data at rest. Then that also is seamlessly integrate with the Tomcat container image. So all the session object that we store, it automatically stored in the Elastic Cache. So, but the only thing is, the issue is like there is no proper UI to view the data in the Elastic Cache. but it's worked really great. So that's the one challenge. I mean, just going one by one. And that's batch processing. As you mentioned that, like, how do you schedule the batch after you move the application to AWS? Because Autosys we're not able to use it. So what is the alternative way? And so initially, right, we deployed the batch application in EC2 instance. But the challenge is like these batch jobs are like running weekly, monthly, and daily, so you don't run all the time. But the problem is like when the moment you deploy EC2, so EC2 will run all the time, then the cost is a little bit higher compared to a container. So then we decided let's go to EC2 instance, which is Fargate instance. So we create a task, and we created a Docker container deploy in the EC2 task. The best part is like EC2 task, we can schedule it, and based on there'll be a cron rule, and weekly, monthly, daily. So it will spin up the particular time. It will spin up the task and run the process, and it will shut down. So you don't need to run all the time that instance. So it will be only a particular part of processing time. So these are things like right now we are looking at like can we manage the job dependency, because these are like single independent batch job. We can easily schedule it, but when it comes to a batch job, right, it can be a monitoring and there'll be a job dependency management. So all these. Okay. So right now we are working on like how the ECS task can manage, how to manage the dependency between the ECS task, so that like when one job is failed, then the other job will not be executed. So that we are currently working in, So these are to address now. Yeah.
Yeah. Thanks, Sudhakar. And now, as Sudhakar was speaking, Chirdeep ran the Terraform in order to trigger the deployment. So looks like that's complete. So Chirdeep, can you explain that? What you did and where you are before you show the final.
Yeah, we just ran the Terraform scripts to provision ECS cluster, which we launched as ECS, Presto ECS. Then we launched the Terraform. So we ran the Terraform scripts to launch the ECS cluster. Then we launched individual service deployment, and as you see in the AWS console, the ECS cluster has been created, and 11 services have been deployed and Fargate, and all are running. So I will now give the API for this. Now this is from AWS.
Yeah, so we can see up at the top that's like hitting an ELB on AWS now, so it's not the local version anymore. It's awesome. Yes.
So for benefit, I'll open the same thing from Postman also. We'll see the data is coming back from our APIs. Right?
Awesome.
And the web front. So this is on AWS now. This was on-premise. This is on AWS.
Oh, that's awesome. So yeah, like I wasn't timing it, but like how long did it take to run the Terraform script? It was only what, like maybe 4 minutes? Like once we had that generated, it's pretty quick.
You see, we have AWS has generated the complete Terraform, and it has, I'll show you. So it has all the components, okay? And the module integrates all of, module has the services deployment, and the common tasks are all parallelly together. So it generated a complete series of tasks to launch the ECS cluster, and then I ran the model services to deploy the 11 services. It hardly took 4-5 minutes.
Awesome.
So now this is the AWS version.
Does your website have any peacocks under the birds? None, but the Amazon parrot though. We had a shout out for parrots in the chat. So that's awesome.
Amazon parrot.
75 years. I don't think I have that many left.
Yeah. So this was typically a very small size application. Let's say 100,000 lines of code, which you finish assessment in kind of 2-3 minutes, and replatform the application in 10-15 minutes, and deploy the application in another 5-10 minutes. However, there are applications which are kind of mammoth size. For example, 1 million or 1.5 million lines of code. For that, those kinds of application, it may take a little bit more time for running and also a little bit more time to integrate. So as Vinod said, typically the time frame will be somewhere around 4 to 6 weeks. However, for very large applications, it can range about 10 to 12 weeks.
Okay, yeah, that's still pretty good. Like for millions of lines of code, like obviously you're going to have the more code, the more complexity, the longer like a full migration may take, but like that's not really too bad, like, 8 to 10 weeks. Especially if it gets you to like take advantage of those like the benefits of the cloud that Stuti was talking about earlier. If you can get that up and then start taking advantage of other AWS services quickly, I think that's a huge win. I think what we do see a lot of is you kind of do see the two methods of migrating to the cloud. One is where you just like, let's just start building straight on the cloud, which is it's a good way to do things, but like sometimes you can't do that. Sometimes you have your mission critical applications and you can't just start over. And so this is like a great option if you just want to kind of start getting in there, get in as fast as you can. Like I think that this is a really, really awesome way to do that.
See, not just that, and there's one more important thing, right? So a lot of applications which are 7 to 10 years old, there's so much of proprietary knowledge, business rules that's really built into it. It becomes very difficult for you to reverse engineer, extract that, and build a new application from the scratch. So what we do in Amaze is it's smart enough to do only the technology conversion while keeping all the business logic intact. So in that way, your on-prem application can be cloud enabled, it can work on cloud, and it's going to cut down your risk also significantly. So that's another added benefit that it brings over.
Absolutely. So how, like, if people wanted to get started, if they wanted to try out Amaze, maybe they're working for their company and they've just been tasked with a major migration to the cloud, how would they engage with you all if they wanted to learn more?
So they can reach out to us, and then we typically start off with an assessment and then followed by a pilot. And this being a new technology, and there is nothing else comparable in the marketplace on which we also have a patent pending. There's always a doubt over is it really good, or how good is it? So which is why we follow it up with a pilot. We take an application and we go through the whole thing to show them that this is how it works. Then they get the confidence and we start engaging with them through a series of applications.
Yeah, and I think something that's important to point out is a lot of the guests that we have on Howdy Partner are SaaS partners. So basically their product is their company. What makes you guys really special is you guys are one of our SI partners. And so you're one of our consulting partners. And so you have this amazing product. You have, this way to like really cut down on migration time and hopefully increase agility of a company, but also you're pairing that with your consulting expertise. So you're not just getting a couple clicks on a product, like you're getting the full package between Amaze, but then also the professional help that you all offer.
That's correct. And in fact, it's not as simple as, a couple of clicks and you have a fully functional application ready. We're not saying that. However, what we are claiming is Amaze does bulk of the heavy lifting. There is a manual effort, but however, that gets reduced when you put everything together. Then you have a package where what would typically take 6 months or 9 months for you to do it, we can shrink that whole time cycle down to about 6 weeks and significantly reduce your cost as well. So it's going to accelerate your cloud journey a lot more faster. And also a lot of times, prior to it, customers had pretty much two choices. One, either do a lift and shift where you lift your VM, put it on cloud, or do a rewrite. So now what we are giving them is an ideal middle ground where you can take your existing application, put it on cloud, and make it more efficient. So it's a good middle ground.
Yeah, so I mean, it's a lot like what you showed at that very beginning slide, that initial report where, we see how much can be automated versus how much manual. I think what's great is that you really do offer all of that. So, you offer the side of things where it's you can do the automated part, but then, that last 25% or the 30% or whatever your code base allows you to do, you've got that as well.
Right. And also it gives us the chance for us to customize it specific to each customer, because every customer has a different security requirement, has a different technology stack requirement that helps us to accommodate that as well.
Okay, so we just had a guest join us here. Welcome.
How you doing?
Yeah, hi David.
Hey David, welcome to the show.
Thank you. Can you guys hear me?
Yes, we can hear you loud and clear.
Clear.
Excellent.
So David Baldwin is he's one of our top customers of Fannie Mae, and he is here, and he's been kind enough to be here, and he is a VP of Cloud Engineering at Fannie Mae, and he's been driving a lot of cloud initiatives. So we thought we'll invite him to talk about Fannie Mae's cloud journey and how Amaze has helped them in their cloud journey as well. I mean, so that you can hear from a customer rather than from us, from a customer over how the journey is working. So that.
Yeah.
Cool.
So over to you, David.
Okay, great. I guess I'll give you guys a little context. So I work with Fannie Mae, and I'm the head of the what we call the Cloud Center of Excellence, which is we're tasked with helping to safely enable our applications to migrate to the cloud. We're obviously looking for speed because we're trying to get to the other side of our cloud journey, and but we're also looking for safety and soundness, right? Which is a big thing for a regulated company like ours. So we started out, years ago in an organic model, moving to the cloud. We've learned a lot, and I guess about a year ago, we decided to make a real program out of it and move full force. So, when we started this, we basically decided that we would have a multi-cloud strategy. So we use AWS for a lot our business applications. And then obviously we use other cloud providers to support things like our workplace environment, like our Windows, our email, and those types of productivity type tools. So so as we start to do this, we had to come up with a sort of a process by which we migrate. And I think we used a similar framework that most people who are migrating to AWS use, which is the 6R framework, where you look at whether you rehost a workload, refactor a workload, replatform. In some cases, you repurchase, like when you can find a commoditized SaaS provider providing the service, or you might retire these applications, and in a small case, we might even retain in a data center But obviously we're going to be looking for a smaller footprint data center as we, move more to the cloud. So, as we did this, we decided as a company that we would migrate more in the more in the replatform and refactor method than to do rehosts. And we did that largely because we don't want to take all this technology debt that we've been carrying in our data centers to the cloud with us. And so that actually, I guess, makes the journey take a little longer. And basically when you're thinking about replatforming, you're looking at things like taking advantage of AWS native managed offerings instead of, the lift and shift model where you're essentially just moving your software, tech stack and all to an EC2 and running it. So when I look at all the different migration services, they seem to be pretty tailored for the rehost. It seems to be pretty common in the industry that most people look to accelerate migrations to rehost. Now, Amazon has a lot of great services that we take advantage of in terms of the data migration service to migrate. We're starting to look at Cloud and Door. We're starting, we've looked at Amazon migration services, and again, in some cases they focus more on rehost, and we really wanted to do a replatform and a refactor type model. So as we did this, we went through a lot of different options and scenarios, and a lot of it we started out doing it ourselves, right? We landed on leveraging Docker containers for our software products, and putting in place all the security controls, around scanning the containers and having a complete sort of artifactory process that we use to drive our containers into the cloud, which meant a huge uptick on the development side in terms of learning curve, right? Because we did not have containers in our on-prem environment, and our developers, frankly, don't know that much about how to do containers without a lot of training, right? Granted, it's an industry standard thing now. A lot of companies are using it, but for Fannie, it's relatively new. And when we did that, we started to notice the uptick. It takes a while to teach people how to do it. We get a lot of benefits because now we can run ECS, we can run EKS, we can use Fargate, serverless options, which really helps a lot with the routine management of servers. We really hate the whole patching process, and it's nice that in some cases Amazon can do that for us. So basically, as we moved to that model, we looked at a couple different offerings, and initially it's interesting. This is before A to C actually came about. So obviously, app to container is a product that Amazon's been introducing us to a little bit, but one of the challenges that we were looking at was, before a lot of that stuff existed, sort of how do we do this, right? And how do we maximize the speed that we bring developers up to speed, and then drive these workloads to the cloud faster. And so obviously one of the products that we looked at was working with Hexaware. We use the Amaze platform. We actually focused heavily on moving a lot of our WebLogic workloads, because WebLogic is something that we didn't traditionally run in the cloud anyway. And so not only did we have to move to the containers, but we were looking at how do we replace WebLogic with a different underlying app server infrastructure. And as we're doing this migration, and Amaze worked out pretty well. So we've been using it now for, I guess, the better part of 6 to 8 months. We've migrated several applications this way, and we're actually going to continue to use it as we drive our WebLogic migrations. So that's a little bit about our background. And I don't know if you guys have any questions or anything that you'd like to ask.
Yeah, I'm kind of curious. What kind of apps are you? What kind of code base are you working with? Are you on the C# or the Java side of things?
Java. So we're in fact, I sometimes think we have the Java union, in our company, because we when we do try to explore things like .NET and C# and things, we end up in a very with a very traditional developer set, the developers that have sort of lived off Java for most of their career. So
Sure.
Java, it's primarily Unix on-prem, so we're a big SUSE Linux shop, and then we're also an Oracle shop, right? So we have Oracle as our backend database as we on-prem.
Sure. And so I'm curious, like, using Amaze, like for one of just choosing like one of your applications, how much would you say that accelerated your ability to migrate versus doing it without such?
It accelerated in a couple ways. So, you know, I'm not going to give you a time because I think the time is different depending on the application. You know, but certainly there was an acceleration, and I think the way I look at it is, it also means that you can get a lot of work done pretty quickly, and by the time the developers are even ready to engage in the migration, you can have some of that stuff pretty much knocked out and ready to go.
Yeah.
I think some of the biggest stumbling blocks we run into when we're looking at our migration, I guess, you know, we've never done infrastructure as code before, right? We've never done containers before. So there's a lot of new concepts as we move to the cloud that we're embracing. And actually it's funny because when we first started our migration to the cloud, you know, we didn't do any infrastructure as code. We actually figured, okay, we can go in and we can configure the system that way and set it up for the developer in a traditional model. And what we learned was when we do that, we can't get our security stuff in place, you know. So when you do network segmentation and things like that, it certainly helps to have a lot of this stuff automated so that you can pre-populate your environment into the right subnets and with the right security groups and all that type of stuff that you would do in code. So a lot of the work that we've done is now we mandate, like in all of our AWS accounts, we mandate this automation. We only give access to the automation tools. We don't give access to humans. Then we end up in a situation where we need to drive automation quicker, and then we need to drive, you know, this new thing called containerization quicker. You know, and then I guess the final big thing is always the database. You know, how do we get the database over with? You know, a lot of our migrations to date have been moving over to an Aurora Postgres model. And the challenge there is when you're migrating, even with DMS, you're restructuring the database, and you've got to go and address a lot of your SQL, right? So tools like Amaze kind of help you refactor some of that and sort of you get some of that stuff out early, so that can just be part of the migration process, even in some cases, like I said, before the developers directly engage in the migration itself. Does that help?
Yeah, no, absolutely. Yeah, we got to see a little bit of we got to see some of the database migration stuff earlier in the show today. Got to see some of the sample code that was generated there. And I think back personally to a time that I was working on a project. We were modernizing an application, and the last step was that database, because there was just it was just so complicated. Nobody had really touched it or changed. Like, well, people had changed it. They'd certainly changed it, but like it had been like just 10 years of just adding tables, like it was just such a hard thing to go through and decode. And I think that like when I saw what Amaze was creating there, I was like, oh my gosh, that would have been so nice to see, you know, some of that automated away from what I'd had to do in a previous gig. So
hey,
yeah,
we've got some of the problems, right? So we and you say 10 years. I'm thinking some of our systems are, you know, 20 plus years old, and to your point, you know, we like everybody else in the industry, I think these days are going for immutable infrastructure. That's a pretty normal, you know, construct these days. You want your infrastructure to be a little bit more ephemeral in nature. You want it to be immutable. You want to be able to, you know, basically build it, throw it away, build it again. Yeah, all that works until you get to the database. You know,
that's exactly right. Yeah, spinning up some servers, migrating a little bit of code, that's all right. But yeah, the databases, that's where a lot of the heavy lifting comes along for sure.
Yeah. So
awesome. Yeah. So I've got a question from the chat, and this might be more for Vinod. In the demo that you showed, what was the Vue technology? Like, was it like JSP, React? What was kind of that the front end Vue part of that?
See, on the demo that you saw, that was JSP, and
Okay.
Amaze does not do a whole lot of, you know, replatforming on the UI. If the question was, can Amaze convert JSP to React or Angular, the answer is no, we can't do it. However, what we do is we replatform the web client to remove all dependency on WebLogic or any other app server, make it stateless, and deploy it into a Tomcat container. That's the part we handle. But the demo application, that was on JSP.
Awesome. Yeah, that makes a lot of sense. Thanks for clearing that up. Yeah, so
Does that answer your question? Yeah.
yeah, absolutely. That totally answers the question. Yeah, I could understand
There's
like going.
another question.
Go ahead, Stuti. Yeah.
There's another question. Can you get to the container this creates and use it somewhere else other than ECS?
Sorry, could you repeat the question?
Yeah, so with this entire process of containerization and refactoring the application, can you get to the container that this creates and use it somewhere else other than the ECS?
Yeah, yes, you could. In fact, for few of our engagements, customers for various business reasons, they were not ready to deploy the application on cloud because of the inter-application dependencies. They had it running on an on-prem environment in OpenShift. And as soon as you had finished replatforming the entire cluster of 20 or 25 applications, they decided to deploy that into cloud. So in which case, until it was ready to be deployed in the public cloud like AWS, it was deployed on an OpenShift on-prem as well.
Yeah,
So yes, we do support those deployment models as well.
I can see how that could be like relevant to certain companies where it's like you kind of want to be like locked and loaded, just ready to push to the cloud, but maybe it's not yet time for that. So I could see why that would be, very nice to be able to do.
Right.
Yeah, especially when apps have upstream and downstream dependencies.
So one of the big challenges, right? Yeah, it's the dependency, as you said. That's the big challenge. You might want to handle all of it before you can move either that one or a group of applications to cloud.
Definitely. Cool. Does anybody else in the chat have any questions that we can ask? Feel free to keep typing in before we wrap up. So just to summarize, Stuti, do you mind just if we had any super late joiners to this this stream, could you just give a quick recap of everything that we've learned?
Sure. So we saw we had Amaze, our partner today in our show, and Mobiquity. Amaze is a product that we were talking about, and how you can utilize that toolkit to have an automated script generated for your migration. You can define and choose your own automation, whichever you would want. Is it like a user specified, or is it like the default one? And then you can pick and choose the source and the target, and go through some run that entire migration, and then you have the automated generated scripts which supports the Java framework, and there are so many frameworks that it supports. And then we saw some great charts, some great scripts that were generated by this tool and by this product. And we had an amazing guest over here. There was a surprise for all of you to talk about how Amaze has really helped them to accelerate their migration strategies. Tazi, would you like to add any point here that I might have missed?
So yeah, I wanted to comment on that. Like the customer story, this is actually the first time that we've had like a guest appearance from a customer on this particular Twitch show. So yeah, super fun, super exciting to have a little bit more voice of the customer. It's one thing to have partners come on and talk like, the full episode, but like, hearing from people who have gone and used it and stuff, I think just really adds some meaning to it. So we really appreciate your time, David, for jumping on here.
Great, thank you. Glad to be here.
Yeah,
and
thanks,
then,
David.
Vinod, were there any other takeaways that you'd like to leave our audience with?
Yeah, the other important thing, I think we spoke quite a bit about the application. One of the other places where it becomes very challenging is going to be the schedulers, especially if you are using AutoSys or Control M, because these two don't work in cloud, and handling those inter-application dependencies for schedulers is a big challenge. which is why we added that feature in Amaze quite recently. So that's also another important element to consider when you're replatforming. And also one of the things what we are trying to look at in Amaze is to make sure that we can holistically replatform the entire application ecosystem with keeping the application at core towards your database, your integration brokers, message brokers, schedulers, etc., so that you can move the entire package to cloud. That's our primary focus.
So if I don't ask this next question, I don't know if I'm allowed to continue working in my current role. Is there any serverless type stuff on the horizon for the Amaze?
That's a great question. In fact, we do support it. For example, some of the services, it can be deployed into a serverless mode. So that's definitely an option, which I think I'm glad you brought it up and which we forgot to mention. So we do support. And I think in this case, I would like Chiradeep to comment on it because he's the brains behind this whole concept. So he can probably explain this a lot more better and some of the new things that we are doing over the next month as well. So Chiradeep, can you comment on that?
Sure. Taste, just to touch upon the first slides that we discussed, we are on Fargate, which is kind of the first step towards serverless containerization. Second step would be to migrate some of the macro services to Lambda. I guess you can hear me, right?
Yep, we can hear you.
Yeah.
Yep.
Okay.
Yep.
So the macro services that we are generating can be deployed, and a macro application itself as a jar can be deployed in AWS as a Lambda executable, and individual APIs can be exposed as a Lambda function without any further change.
Awesome.
That's
So
great to
good.
know.
So serverless, it is a part. It's on your roadmap. It's something that you're definitely keeping your eye out for, and it sounds like there's some functionality already for that, and I think that's huge. So, what other kind of roadmap stuff should we look for in the next 3-6 months?
So the other important thing we are focused on is going to be the on-prem ESBs or integration brokers, migrating application of that. For example, you've got some applications running on TIBCO's BusinessWorks, and TIBCO BusinessWorks does not work on cloud. So migrating those applications to AWS so that customer A can get on cloud, and B, they can completely get rid of TIBCO's license. So that's one. The second one is applications running on Oracle's OSB. So that's another one that we are focusing on. So we do have customers who are running applications on these that they want to move to cloud, and so those are all the other things that we are working on. So Q4 of this year is going to be focused on these two areas.
Awesome. That's great. Another question that I have that I like to ask a lot of partners is, how would you describe your ideal customer? So like, what does that look like? Who should be watching this right now and thinking, oh, Amaze, this is what I need? Like, what does that type of customer look like?
So our ideal customer would be a customer who's committed to cloud and who's looking to accelerate their cloud journey. That's one type of customer. So anyone who just wants to have an increased velocity. Then the second type of customers are customers who are looking to digitize their application or digital enable their applications. For example, that's the scenario that we walk through. They may be having a lot of applications built over the last 10 to 15 years. They are looking to modernize it so that they can build a new mobile UI or a web UI onto it. Getting into a headless architecture or to better integrate their applications on cloud. Those are the two important segments of customers.
Sure. Yeah, that makes total sense. And so, yeah, I think that pretty much captures the main questions that I was curious about. And we're coming up on the hour. Does anyone else have anything else that they want to add, or are there any last minute questions in the chat? Well, I guess it sounds like we've pretty much done it. And so, key takeaways: if you're looking to do a migration, reach out to these guys. Reach out to Mobiquity. They do amazing work, and they've got an amazing product to help accelerate your move to the cloud journey. On this call, we have a peacock and 3 dogs. I think that was a big takeaway. And last but not least, just thank you all for joining. I really hope that you are able to learn something. And again, reach out to Mobiquity if you have these types of questions about your migration. And thanks for everyone for joining. And so the last thing that we do on every single episode is we have a group sign out where we all attempt to say the same words at the same time. And it's always really successful. And so the 3 sign-offs that we have for the episodes are, y'all come back now, giddy up, or happy trails. So what do you guys like? Option 1, 2, or 3?
Maybe go with 1.
1? Y'all come back now?
Yeah.
Hey, it sounds good. That's the vote. So on the count of 3, we are going to all attempt to say, y'all come back now. And that's how we're going to sign off. So again, thanks everyone for joining us for another episode of Howdy Partner. Hope to see you all again next week. We air Mondays and Wednesdays, 2 p.m. Pacific. And so with that, let's sign off on 1, 2, 3. Y'all come back.
Y'all come back now.
See ya, everyone.
See ya.
See you, everyone.